What would happen if we replaced the methylene, CH2, of butene with an oxygen? We'd have propanal. Let's consider its conformation energy profile. To start with, we will view propanal down the bond green from carbon 1 red to carbon 2 blue. This is a Newman projection of propanal and represents the anti-staggered conformation of comparatively moderate energy. There is a dihedral angle from carbon 1's red hydrogen to carbon 2's blue methyl group of 0 degrees. Carbon 2 blue is rotated by 60 degrees anticlockwise to an eclipsed conformation that has a dihedral angle of 60 degrees with a slight reduction in energy. An additional rotation through another 60 degrees sees growth of energy to provide the Gauche conformation of the highest energy of all of the conformations with a dihedral angle of 120 degrees. A further rotation of 60 degrees affords a loss of energy to the syn-eclipsed conformation of the lowest energy of any of the conformations with a dihedral angle of 180 degrees. The next 60-degree rotation affords increased energy to another Gauche conformation with a dihedral angle of 240 degrees. A further 60-degree rotation reduces energy to provide another eclipsed conformation with a dihedral angle of 300 degrees. The final 60-degree rotation returns to the initial anti-staggered conformation with a dihedral angle of 0 or 360 degrees. The syn-eclipsed conformation is the lowest energy conformation. The highest energy conformation is the Gauche conformation and has 8.8 kilojoules per mole more energy than the syn-eclipsed form. The next highest energy conformer is anti-staggered with 4.2 kilojoules per mole more energy than the syn-eclipsed form. The eclipsed conformation is only 3.3 kilojoules per mole greater in energy than the syn-eclipsed conformation. All the conformations are of relatively low energy, so there are populations of all conformations at 25 degrees Celsius. When we consider the specific case of propanal, the syn-eclipsed conformation has a lower energy than the eclipsed conformations, but limited changes to the molecule can invert this relationship. Where the alkyl group is changed from methyl to T-butyl, the larger alkyl group causes significant steric hindrance with the aldehyde oxygen. As a result, the syn-eclipsed conformer is now higher in energy than the eclipsed conformations.